I'm Marcyrus G. Arceo from Grade 10 Bernoulli. And for today's video, we're going to tackle about solving probability of mutually exclusive and not mutually exclusive events. What is mutually exclusive and not mutually exclusive events? First, let's talk about mutually exclusive events. Two events are mutually exclusive if both events cannot occur at the same time. These events have no common elements. Mutually exclusive events, also called as disjoint events, while in not mutually exclusive events, two events are not mutually exclusive if both events can occur at the same time. These events have common elements. Not mutually exclusive events, also called as inclusive events. Now, let's proceed to the formula of mutually exclusive and not mutually exclusive events. In mutually exclusive events, we use the formula probability of A or B is equal to probability of A plus probability of B, or probability of A union B is equal to probability of A plus probability of B. While in not mutually exclusive events, we make use the formula probability of A or B is equal to probability of A plus probability of B minus probability of A and B, or probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Before we proceed to our examples, first, let's have a practice. Determine if each pair of events are mutually exclusive or not mutually exclusive. Write your answer on the block before each number. Number 1. Electing the treasurer and the sergeant at arms of the class. As you all know, we can be elected once. If we are elected as the treasurer, we can be elected as the sergeant at arms of the class. So this event is an example of mutually exclusive events. Number 2. Getting an odd and a prime number in rolling a fair die once. First, let's determine what is the sample space in this event. The sample space in these events are 1, 2, 3, 4, 5, and 6, while in a odd number contains of numbers 1, 3, and 5. In prime number, we have numbers 2, 3, and 5. As we can see, we have a common elements here. So we can consider this as not mutually exclusive events. Number 3. Working in Dubai and you are a Filipino. As you all know, we can work in Dubai even though we are a Filipino. So this event can occur at the same time. So this is an example of not mutually exclusive events. Number 4. Picking a red and a green marble in a bag. These events cannot occur at the same time. So we can consider this as mutually exclusive events. Number 5. Drawing an ace and a heart from a standard deck of cards. As we all know, we have 4 aces, which is ace of heart, ace of clover, ace of diamond, and ace of spades. As we can see, we have here a ace of hearts. So, this event can occur at the same time. So, we can consider this as not mutually exclusive events. And now that we're done answering our practice, let's proceed to our examples. First, let's solve for the probability of mutually exclusive events. Example 1. A basket contains 8 blue balls, 3 green balls, and 4 yellow balls. William draws one ball at random. What is the probability that the ball is either blue or yellow? The probability of blue or yellow is equal to probability of blue plus probability of yellow. We all know that the probability of blue is 8 and the probability of yellow is 4. So let's substitute them. Probability of blue or yellow is equals to 8 over 15 plus 4 over 15. We get the denominator 15 because we add 8, 3, and 4. And it will give us an answer of 15. So we get a denominator of 15. Now, let's add numerator to numerator and just copy our denominator. Probability of blue or yellow is equals to 12 over 15 or 4 over 5. We get an answer of 4 over 5 because 12 and 15 are both divisible by 3. We divide 3 12 divided by 3 is 4 and 15 divided by 3 is 5. So we get a final answer of 4 over 5. Therefore, the probability that the drawn ball is either blue or yellow is 4 over 5. Example 2. A card is drawn at random from a standard deck of 52 cards. Find the probability of drawing a numbered card or a face card. Solution. Probability of numbered card or face card is equal to probability of numbered card plus probability of face card. We all know that the probability of numbered card is 36 and the probability of face card is 12. So let's substitute them. Probability of numbered card or face card is equals to 36 over 52 plus 12 over 52. 36 is our favorable outcome and 52 is total possible outcomes. Same in 12 over 52. 12 is our favorable outcome and 52 is our total possible outcomes. So let's add numerator to numerator and just copy our denominator. And we will get probability of numbered card or face card is equals to 48 over 52 or 12 over 13. We get numerator 48 because we add 36 plus 12. And we just copy the denominator. We simplify 48 over 52 because 48 and 52 are both divisible by 4. 48 divided by 4 is 12 and 52 divided by 4 is 13. So, the probability of getting a numbered card or face card is 12 over 13. Now, let's solve for probability of not mutually exclusive events. Example 3. A spinner is divided into 8 congruent parts. If it is spun once, find the probability of getting a multiple of 2 or a prime number. First, let's determine what is the cardinality of the sample space. As the statement says, a spinner is divided into 8 congruent parts. So we can clearly tell that the cardinality of our sample space is equals to 8. Let A be the event that is multiple of 2. So it contains the numbers 2, 4, 6, and 8. So our cardinality of event A is equals to 4. And let B be the event that it is a prime number. So it contains the numbers 2, 3, 5, and 7. And we get the cardinality of event B is equals to 4. And A intersection B is equals to 2 because we can clearly see here that they have common elements, which is 2. And our cardinality of A intersection B is equals to 1. And now, let's substitute probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Probability of A in union B is equals to 4 over 8 plus 4 over 8 minus 1 over 8. Let's add 4 plus 4 and subtract 1. So we get an answer of 7 over 8 because 4 plus 4 is equals to 8 and minus 1 is equals to 7 and just copy our denominator 8. Therefore, the probability of getting a multiple of 2 or a prime number is 7 over 8. And now, let's proceed to our last example. Example 4. A fair die is rolled once. What is the probability of getting a multiple of 3 or a composite number? First, let's determine our cardinality of sample space. We all know that in a pair of die, we have 6-sided die. So, the cardinality of sample space here is 6. And let A be the event that is multiple of 3, which contains of numbers 3 and 6, and will give us the cardinality of A is equals to 2. And let B be the event that is composite numbers, which contains of numbers 4 and 6, and will give us the cardinality of event B is equals to 2. And our A intersection B is equals to 6 because we can clearly see here that they have common elements, which is 6, and our cardinality of A intersection B is equals to 1. Let's substitute probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Probability of A union B is equals to 2 over 6 plus 2 over 6 minus 1 over 6. Let's add 2 and 2. So we will get an answer of 4 minus 1 is equals to 3. And just copy the denominator and will give us an answer of 3 over 6 or 1 half because 3 and 6 are both divisible by 3. So 3 divided by 1 is 3 divided by 3 is 1 and 3 and 6 divided by 3 is 2. So our final answer here is 1 half. Therefore, the probability of getting a multiple of 3 or a composite number is 7 over 8. That would be all, and thank you.